Hello everyone, so in this video let us talk about a problem from LEETCODE. The problem name is count vowels permutation. So the problem statement goes like this, that you're given an integer n. Your task is to count out how many strings of length n that can be formed under the following rules. The rules are that each character in the lowercase of the string that you're forming should be of the type A, E, I, O, U. Each vowel A must only be followed by E. Okay, so like if you write down A, then it should be always like if you have A, then the next character should be E. Then each vowel E must only be followed by A or an I. So if you have written down E at any point of time, you have to again do an A, the next character of it, or it should be an I. If the next vowel, if any vowel is I, then it should not be followed by one more I. If any vowel you're talking about is O, then it should only be followed by I or A or U. Okay, sorry, I or a U, and each vowel U must only be followed by an A. Now you have written the different number of strings you can form. You have to just do a modular of that with 10 of 9 plus 7. So if you have seen my modular arithmetic video, go check it out. I've explained the very simplest technique to do modular arithmetic on different occasions. If you have seen this type of thing in any problem, how you can do a modular arithmetic using just 2 or 3 functions, then it will become very easy to just do mod m, and how to do all of those stuffs. It's become very easy in understanding that. So if you haven't checked out that video, I will be linking out that video description, like that link in the description of this video. So you can check out this video. That will be very helpful for you. Okay, but now coming down to this problem, what you can directly understand is that you have to see that, okay, in this problem we have to count out different number of strings I can form. Okay, then the overall thing is that how many strings I can form with this given n. So maybe n equal to 1, then 2 and 3 and so on. So if n equal to 1, I have all the 5 strings I can make with A, E, I, O, U. But then if n goes to 2, then for every starting, let's say I start with A, then for A I have different conditions. Like for A it can only be followed by maybe E. And then then I start with E, the first character of the string that I'm forming will be E, and then I'll do these conditions and I and O and U. So there are like different conditions which I'll be starting about. And then from those I'll go to next state. So from one state to going to next state, you have to see what is the number of ith character you are on. So I depends, as well as what is the previous character in the string that you are forming, because the previous character is somewhat, the next character appending to that previous character depends upon different state values. So that is the overall thing that you have to understand, that in this dynamic programming problem, this is a dynamic programming problem, because in the ith state, so in the ith position, you have see that what is the next character that you would follow. So if the next character that you have to follow is depending on the previous character in the string that you are forming. Okay, so what you can actually do is that you can assume a map that you do A is equal to 1, E equal to 2, I equal to 3, O equal to 4, U equal to 5. So that it is easily mapped according to you. By mapping, I means that because you have to keep track of the previous character, okay, in the state which you are doing this DP on. Now if you take the previous state to be A, then you have to do maps, because the characters in like it's difficult to store. But what you can directly do is that instead of using maps, you can directly use a DP table like a matrix. But for that, what you can directly easily do is that you have to understand that I am mapping A to 1, E to 2, I to 3, O to 4, U to 5. Cool. So now what's left now? You just have to understand that for every state you have to see what is the next state that will follow. So I'll directly move to our DP table. So so for every recursive problem or DP problem, you have to first understand what is the recursive thing that you have to do. So at every state, let's say that you have from the 0th state, so you have 5 options. From the first state, you have all the 5 options. You can put A, E, I, O, U. And from A, now you have only one option to put an E. So it is AE. From E, you have only you have 2 options. So you have options to, from E, you can put A or I. So it's EA or EI. Okay. And then from I, you can put all the 4 characters except I itself. So A, so it is IA, like IA, IE. So I doesn't exist, like it will not follow. So I, A, E, I, O and IU. Then from O, you again see that it has I or U. So OI and OU. And from U, you can only go to A. So UA. And similarly for all of this you can do. So what you can actually see that some states might occur like multiple times. So it depends upon the ith state value you are, what is the length at this point, and on which character you are trying to append, because after this A, you again see that because it's a, what you only have to append E after that. So it's E. So the previous character. So you just take a DP table of the total number of characters. So N, look on the ith character you are, so on which ith character you are, so I, and what is the previous character that you have appended. So for the previous character you are just mapping A to be 1, B, it's not B, so it's A, E, I, O, U. So you're mapping this 2, 3, 4 and 5. Okay, that's the whole thing you have to understand. Now move on to the code part, so it will become more clear to you. So what we have done here is that we have called this, so we have memset a DP table, everything is initialized -1. So this is the DP table, because the maximum length can go up to 2 into the power 4, 2 into the power 4, just 2 as in buffer that is added. And because there are 5 characters from 1 till 5, so because from 1 index to 5 index, so I have taken till 6. This is the modular value. For doing modular arithmetic, what I actually preferred is that I add on these 2-3 functions for doing a mod of any value. So x mod, like maybe x mod m, you just write down this function. And for doing modular arithmetic of a plus b mod m is equal to a mod plus b mod whole mod. So it's like a mod plus b mod plus whole mod. So that's what we're doing. And now in this function, we call this solve function with 0, 0, n. So 0, 0 means that what is the 0th character you are starting upon? This is 0, from like what is the character you want to start with, and like what is the previous character. So for this state, the previous character is nothing, and n is the total length. Okay, now we call this function. And what is the base case? The base case is that if I go out of bound, if I greater than equal to n, we return 1. 1 means that we have completed a particular string that we are building, because we are saying that we are following the particular rules. So if we are following the rules, when we have built a particular string using these particular conditions, which actually means that we have found out a particular answer. So find out particular answer, I return 1, that one string is found out. If the state we have already seen, we return that particular state value. This is the answer value. Now we have two conditions. The first condition is that if I equal to 0, I equal to 0 means that we are filling out the first character. If we are filling out the first character in the string, we have to put all the characters one by one. So we have all the 5 choices. So we just iterated over all the 5 choices from 0 to 5. So I have not mapped 1 actually A to 1, but it is like mapped A to 0, E to 1, because it is 0th indexing. Then this is 2, this is 3, and this is 4. So A is mapped to 0. So we have done from 0 till 4. We call this solve function with I plus 1 because the ith position is filled. Now I call it with I plus 1. So for the next position, the previous character is k. That for one state the previous character is 0, that is A. For the other character the previous character is E, then I, O, and U, and so on. Okay. Then when we go to the next iteration of this recursive function and we are not on the ith position, then we go on the else position. Now in the else position we have to just do that. Okay, if the previous character was 0, that is A. If the previous character was A, then the next character that we have to fill out, the answer is that the total number of strings that I can form is the total number of strings that is answer plus if I add if the first character is A, I can add the next character to be E, and E is 1, which is mapped to 1. So I'll call the new solve function with I plus 1, that is going to the next state. But now the character that the previous character is equal to 1, that I can add E to it. Okay, and then if I equal to the ith character that I have filled, that is the previous character, is equal to 1, then the next character can be, as you can see, 0 or 2. That 0, 2, so the next character can be A. For the E, the next character can be A and I. And A and I, so A is equal to 0 and I equal to 2. Similarly, for if the current character I am appending is I, so the next character cannot be I itself. So I means that A, E, I. So that is 2. So we iterate over all the particular characters and it should not be equal to 2. Just append and like call the solve function again for all of those different states. Similarly for O and U. So what you can directly observe here is that this is just a brute force way, like not the brute force way, recursively calling out for all the different states depending on what is the previous state that we have appended. And according to that we have called this function, and the total answer is that the total answer, and because the previous state is among all of them, only one of them, so only one of them will be seen. And yep, that's it, that we are like calling out total number of strings that we are building, and in each state we are appending and increment my answer by 1, so I plus 1, because we are like adding one more character to the string that we are building. And at any point when I've completely built the string I greater than equal to n, I return 1, that I have found one particular arrangement of a string. and in the end we update the state, that is def I and previous equal to answer, and just return answer. That's the overall problem itself. Nothing much complicated here itself. You just have to understand how you make the different states. From one state, how you go to the next state. What is the parameters that define this current state? And then just try to think over, try to build the recursive tree. If you can build the recursive tree, you just write down the recursive function, nothing else. And just write down 2 lines. Just add memoization to it. So this is the memoization line. Just add that if you have seen this previous state, append that, like take this previous state, and before writing on the answer, just update this previous state, like the state that you have calculated in this recursive call. That's it. That nothing much overall complex here, and that's the overall idea for this problem. Thank you for watching this video till then. I will see you in the next one. Till then, keep coding and bye.